Hey guys, and welcome back. So in the previous nugget we learned a little bit more about the kernel modules. We could see how we could manually intervene and load and remove and list these modules, but we understand that the kernel itself largely is going to work in an automatic fashion. This is just making our life much easier. We don't have to think so hard, so it really is quite handy. But now we have that information under our belt, I want to turn our attention to some general kernel configuration information. So the first thing I want to talk to you about is a particular location, and that location is in the proc directory, and then the sys directory, and then the kernel directory. Now within here, we're going to house what are effectively the live settings that are running for the kernel. Now, one thing to note is that these settings are very different from the actual modules themselves, so try not to confuse the two. So if I would happen to go into this particular directory, go into the proc directory and then into sys, do an ls, we see we have our kernel directory right here. Right here we can see a whole bunch of configurations and options relating to how our kernel is going to operate. So things like the bootloader type or the bootloader version, or maybe the maximum amount of threads, all of this information we can find within this location right here, proc sys kernel. Now, like I say, these actually denote settings which are running live on the system right now. Now, if you actually want to make changes to the system such that the changes take effect when the boot operation starts, we would have to use a very particular configuration file. So let me show you what this file is going to be. It's going to be in the etc directory, which should come as no surprise. This is a system-wide configuration file. And we go into sysctl.conf, and again, like I say, this file right here is where you can tell the system when it boots up how you want all the settings within proc sys kernel, how you want those settings to be stored, and you can make this permanent by making these changes within this file right here. So if we go to the etc directory, do an ls, and in fact let me just grep for sysctl. Notice we have our sysctl conf file, so if I happen to go in here and hit enter, notice this is the configuration file for system variables, and we can do things like setting the kernel domain name, or we can allow for certain activities. Say for example, if we want to have packet forwarding, i.e. network address translation. This is something we talked about in the LPIC 1 examination. We could, for example, uncomment out this line and allow for this setting to take place upon boot. Now notice that this is all in this file right here, but actually it's worth noting is that we also have this sysctl.d. What this is basically a directory. Now the thing to note about this directory is that within this directory you can ultimately specify similar settings. So again, I go into my directory and hit enter, we do an ls. We see multiple configuration files for different operations, but really what I want to stress is that if you happen to make some type of configuration change to a file within this directory, and it happens to conflict with something you have specified directly in the sysctl.conf file, understand that the sysctl.conf file is going to take precedence, i.e. anything within this file right here will override anything you have within the sysctld directory. So this conf file is going to take priority. If we have additional information which is not specified here, but is specified in the directory, then that can take effect, but any conflicts are going to be resolved by having the sysctl.conf file take that priority. Now, one thing to note is that we can actually make such changes manually using a particular command as opposed to modifying a configuration file, and that is by using the sbin, so sysctl within the sbin directory. So let's actually explore this command right here then. So what I will do, I'll just clear my screen, and what I'll do is I'll actually go back to my home directory right now, and I'll just say man sysctl. Now it's going to say here, this command allows us to configure kernel parameters at runtime. and the parameters are going to be located again within proc sys. And note we can use this command to both read the sysctl data as well as to write new sysctl data. So if we happen to scroll on down, we're going to see a whole bunch of different options. Here is one right here, -a or -- all. This is going to allow us to display all the values currently available. So if we happen to try and use this one, so I'll say sysctl-a, these are all our current kernel settings right now. So things like net IPv4, IP forwarding, this is set to the value 0. Pretty much this means this is inactive and not enabled, this behavior. So we could make a change to this behavior directly within the sysctl.conf file, which would allow this behavior to stick and be persistent over multiple reboots, or we could change this behavior in real time using the sysctl command. So if I would happen to take this configuration right here, let me copy this, and if I wanted to write a new change using the sysctl command, again if I check the man page, we can see we have the -w option or --write, and this is going to allow us to ultimately write in particular changes. So let's press Q, clear the screen. I'll say sysctl-w to write a change, and now I'll actually type in the value I want to modify. So I'll paste this in. Oh, and I've pasted this in incorrectly. What I want to do is to actually get rid of the spaces here, and I'll actually modify the value so that it is 1 instead. So if I hit enter now, notice the value has indeed been updated. So if I now do sysctl-a, and in fact, let me just grep for the word forwards, and that's still a little bit too verbose, just to make it a little bit easier, I'll say grep IP forwards. We can see the actual value here has now been modified. And again, if we wanted to make this change persistent so that it takes effect when the system is booted up or rebooted, whereabouts would we make that change? Well, we know it's going to be in etc sysctl.conf. In this case here, we could just uncomment this out and save the file to get the similar effects, but with persistence. Now, another thing which I want to talk to you about that is very important with respect to the kernel is udev. Now, in modern Linux systems, the files that we have within the dev directory ultimately tell us what is attached to our system. So imagine something like, say, a USB gets attached. Information relating to this device is going to be within the dev directory. Now we have this daemon called udevd, and this actually works directly with the kernel so that we can manage the files that we would have within the dev directory. So you can imagine udev as a type of watchdog, and if a particular device is attached to our system, udev is going to watch the system and then load in the kernel module that happens to be needed. So again, the example being USB is plugged in, udev notices this and then loads the necessary USB module into the kernel, and everything works on the fly. This is what I'm talking about with the automated process. Udev is making this much easier for us than having to manually go in, locate a particular kernel module and load it in as appropriate. Now similarly, if you happen to remove that USB stick, udev again is going to handle the kernel module and remove that module since it's no longer needed, and we know that the kernel is indeed modular. So if this particular module is no longer needed, then strip it down and keep things more efficient. Again, everything handled under the hood by udev or the udevd daemon. So if udev is looking for what exactly is plugged in, how do we see as the system administrator what those devices actually are? Well, we do have a bunch of options available to us and tools to help us with this task. The very first one is LSUSB. Now you can probably guess what this actually does from the terminology. We have ls, that is going to list, and we're going to list the USB devices attached to our system. So what I could do is say man ls USB, and we can see here this is a utility for displaying information about the USB buses in the system and the devices connected to them. And we can see all these additional options that we have to get different types of information. So if I press Q and issue the command ls USB, what I'm actually seeing right here is information relating to my virtual machine. This is because I am running Ubuntu on VirtualBox, but if this happened to be a real live physical machine, then of course I would get information relating to that instead. Now the other command we have available to us is lspci. If I say man lspci, again similar to ls USB, this is not going to show us USB buses, but instead PCI buses in the system and the devices connected to them. And again, just like we saw before, we have a whole bunch of different options. If I scroll on down, we can do things like be verbose or be very verbose, or show kernel drivers, so on and so forth. If I press Q, I can say ls PCI. We can see all the PCI information. I can say ls PCI with a -v to get more verbose information, or I could say -k to get the kernel related information with respect to the PCI devices. Now another command we have available to us is lsdev. This is not going to be installed by default, but what I can do is say apt install procinfo and hit enter. So now if I say man lsdev, we can see here this is going to give us information relating to installed hardware. So we'll see things such as interrupt requests and direct memory access channels. So if I happen to use this command, lsdev, we can see all of that information. Now the way the lsdev command actually works is that it's going to gather information from some particular locations, and these locations will be within the proc directory. So for direct memory access, it will be in proc DMA. For our input-output information, we will get it from proc IO ports to show the input-output. And with respect to our interrupt requests, the lsdev command will look into the proc folder and then the interrupts file. Now one thing you may notice with respect to the lsdev command is that it's a very simple command. It does not have any additional options, i.e. if you happen to do lsdev dash maybe S, it actually has no effect on the output. We get the exact same output. Similarly, if you do -Q, the exact same output, or -F or -Y, it really is a singular command pulling from those files. Now, one more command we have to understand that is very important with respect to udev. In fact, I should clarify we're going to have two important commands. The first of which is going to be a deprecated command that is no longer recommended, but again we have to understand it for the purposes of the exam. And the second command is the modern way to use the command. So the first one is going to be udev monitor, all one word. This is going to allow us to see real-time information relating to our devices as we plug stuff in and unplug them. So say for example you run udev monitor and you plug in a USB stick. This information in real time is going to be displayed when you are running the udev monitor command. And again, like I say, this is a deprecated implementation. So you may see it on older Linux systems, but this is not the recommended way any longer. Instead, we have the command udev adm for administrator, and then a space, and then the word monitor. This is the modern way to get the same type of information. So if we happen to run this command, I'll say udev monitor, which is the deprecated way. Notice it says the command is not found, but if we happen to say udev adm space monitor, we are now waiting and are ready to receive any real-time information relating to our devices as they are plugged in and plugged out again. Now, as it transpires, I am on a virtual machine. I'm not going to be attaching any USBs, but if I did, you would know that this information would be ultimately reported to me on my terminal window via the udev adm monitor command. So this really is a valuable tool for us as Linux systems administrators to be able to monitor our system as external devices are attached and detached. Okay, doke, so that is us for kernel configuration options. We still have more information to get to, so how about we keep on going? So I hope this has been informative for you, and I'd like to thank you for viewing.